Hi science students, welcome back to another day of digital learning. We're going to continue to look at solubility curves today. So you see a solubility curve on the left-hand side of your screen, and we're going to go through and talk about 10 questions related to this solubility curve. Let's get started. So our first question is going to ask us to analyze the graph. It says, at approximately what temperature does the solubility of sodium chloride match the solubility of potassium dichromate? So it gives me the names, and it also gives me the chemical formulas of these compounds. So this question is asking me, at what point do they match? At what point do their solubilities match? And it's telling me I need to tell them a temperature. So I want to go to my graph. I want to find sodium chloride and potassium dichromate. I see sodium chloride is this light blue line, and potassium dichromate is this dark purple line. I want to find the place where these two overlap in solubility, and I can see that that happens here. And if I trace down, I can see that that is 60 degrees. So my answer to this first question is going to be 60 degrees. Let's look at the next question. Number 2 says, how many grams of sodium nitrate are soluble in 100 grams of water at 10 degrees Celsius? So I know that this whole chart, this whole graph is showing me the solubility within 100 grams of water. So that is not as important a piece of information as the other things that are given to me, like my chemical formula or the name that I'll be able to locate on the graph, as well as the temperature that I need to be looking at. And I know that this question is asking me how many grams are being dissolved at that temperature. So I need to go to 10 degrees right here, and I need to trace up until I find sodium nitrate. So I'm going to go up all the way up here to this dark red line. Sodium nitrate is at 80 grams dissolved at 10 degrees. So I'm going to put in 80 grams. Number 3 says, which salt is least soluble at 50 degrees Celsius? I know that in order to see which ones are most soluble, I would be looking up towards the top. Most soluble is going to be, can hold the most amount of solute. So least soluble is going to be the opposite. Which one is least soluble at 50 degrees? So I want to go to 50 degrees and I want to see which line is closest to the bottom axis. It's easy to see that this line here, this dark red, brown kind of line, at 50 degrees is the closest to the bottom. So my answer to this one is going to be Ce2SO3. This is also known as cerium sulfate. Let's go on to our next question. The next question is also asking about the least solubility. So I know I want to be looking at which line is closest to the bottom, closest to the 0 point of my solubility, my grams. So I know if I'm looking at 0 degrees, I'm going to be right here. And I can see there are several lines that are pretty close to 0, but I want to be the closest to the bottom if I'm looking for least soluble. So if I'm looking for the least soluble, I'm looking for the one closest to the bottom. I see that this brown line here is closest to 0 grams. So if I trace up, I can see that this is going to be potassium chlorate right here, KClO3. Potassium chlorate. Number 5 says, which of these salts decreases in solubility as the temperature increases? So I know that I would be looking at my lines and I would be looking for one that starts out at a higher number than it ends out. As I increase the temperature, I should see that my line is moving down towards the right. It's a negative slope rather than moving up towards the right. And in this graph, I really only see one of those. It's that same cerium sulfate. It's right here starting at 20, and as I increase the temperature, I see that it gets down to less than 5 grams at 100 degrees. So I know that that's the only one that's decreasing as the temperature increases. So my answer is cerium sulfate, Ce2SO4 3 cerium sulfate. So let's keep going. Yesterday we practiced with identifying if it was saturated, unsaturated, or supersaturated. And the way we were looking at those problems looked a lot like this. However, I want us to delve in a little deeper and look at them in the form of word problems, being able to pull out the most important information. So we're going to start with this first one to get ourselves comfortable with this practice from yesterday, and then we're going to delve into a little more challenging word problems. So this letter A says 20 grams of potassium chlorate at 80 degrees. So I know that I want to start with my temperature. That makes it the easiest. So I'm going to trace up and I'm going to look for potassium chlorate. I want to see what amount of grams can be dissolved at that temperature first before I start deciding if it's saturated, unsaturated, or super. So I'm going to trace up. I'm going to find potassium chlorate. It's right here. It can dissolve about 38 grams at 80 degrees. So if this is saying that I, as the scientist, am pouring in 20 grams, but I could have up to 38 at this temperature, I know that this is going to be unsaturated because I could still add 18 more grams of potassium chlorate before it is completely saturated. So I'm going to put unsaturated here as my answer. Letter B says when 30 grams of potassium nitrate, and it tells you the chemical formula, is dissolved in 100 grams of water at 20 degrees, the solution can be correctly described as this. I want to point out that this question is asking the same thing as question A. It's just more wordy. It just has extra words in there, giving you more information in a different way. But it's asking you the same things. It's saying there's 30 grams of potassium nitrate being put in to the 100 grams of water at this temperature, 20 degrees. So as we go forward, I would encourage you to highlight or underline or mark in some way the same pieces of information we've been pulling out the whole time. We're looking at what temperature is it being dissolved at, how much water is being used, and how many grams am I trying to put in. So for this one, I want to go to 20 degrees. I'm looking for potassium nitrate to see how much could be dissolved at that temperature before I even decide if it's saturated, unsaturated, or super. So trace up until you find potassium nitrate, KNO3. So I'm going to trace up, it's this green line here. So it's right at the 30 gram mark at 20 degrees. And this says when 30 grams are being put in at 20 degrees. So I know that if it's right on the line, that it's going to be considered saturated. So that's what I'm going to put in. This is a saturated solution. If I added more grams of potassium nitrate, I know that it would sink to the bottom, it would not dissolve, which means that it would become supersaturated if I added more than 30, according to this solubility curve. So letter C is another word problem. When 50 grams of potassium chloride, KCl, is dissolved in 100 grams of water at 50 degrees, the solution can be correctly described as this. So again, I'm going to do that same practice. I'm going to highlight how many grams are being dissolved. I'm going to also highlight what my temperature is because those two things are the most important pieces of information when I'm trying to decide is it saturated, unsaturated, or super. So I want to go to my 50 degrees and I want to make sure that I know what chemical compound I'm looking at, potassium chloride. So I want to trace up to potassium chloride, which is right here, this dark blue line. And I can see on my solubility curve that at 50 degrees, 100 grams of water could hold about 42 grams of potassium chloride. So if I know that my solubility at that temperature is 42 grams, anything more than that is going to make it super saturated. So I can see that 50 grams are trying to be forced into this solution. I know that that's going to be too much. It's not going to be able to dissolve. So I know that this is going to be super saturated. All right. Letter D says a beaker containing 80 grams of lead nitrate and 100 grams of water has a temperature of 30 degrees. Approximately how many grams of salt are undissolved on the bottom of the beaker? So I first want us to start with the same things we were highlighting. How many grams have been forced in? What is the temperature? And what is the chemical compound that I'm going to be looking for in my chart? We know those things. However, this question is asking something a little bit different than what we've been looking at in the first three that we just did. It says how many grams are undissolved. So this is telling you that this is probably going to be super saturated, and it's asking you how many things have sunk to the bottom. So it no longer is asking, is this saturated, unsaturated, or super saturated? This is actually asking you how much solute has not been dissolved and is sitting on the bottom of the beaker. So let's look at 30 degrees. We're going to do the same thing we've been doing. We're going to look at 30 degrees. We're going to trace up until we get to lead nitrate. So lead nitrate is going to be the yellow line in this graph. We're going to trace up all the way up here, and we're going to see that it's about 65 grams are able to be dissolved into lead nitrate at 30 degrees. So I know if I put in 80 grams, minus the 65 grams, which is able to be dissolved, equals 15 grams undissolved. Let's make sure that we understand how we did this. We traced up 30 degrees to the yellow line. When we got here, we saw that it was 65 grams had been dissolved at 30 degrees. The question tells me that 80 grams have been put in. So if 80 grams have been put in, but only 65 can be dissolved, I know that I would subtract 65 from 80, and when I do that, I get 15 grams undissolved on the bottom. Let's keep going. Letter E, a solution of potassium chlorate, KClO3, has 20 grams of the salt dissolved in 100 grams of water at 70 degrees. Approximately how many more grams of the salt can be added to the solution before reaching the saturation point? So I can see that it tells me what my chemical formula is that I'll be looking for. It tells me that 20 grams have been put in. It tells me what temperature they're being dissolved at. But again, this question is not asking, is this saturated, supersaturated, or unsaturated? This question is asking, how much more could be added? How much more can I add to the solution before it becomes saturated? So I know that this is telling me this is an unsaturated solution, and I could add more grams of potassium chlorate before reaching my saturation point. But I need to know what the saturation point is at 70 degrees in order to know how much to add. So let's do that. We're going to trace over to 70 degrees, and we're going to go up to potassium chlorate, which is going to be that brown line. So I'm going to trace up, and when I get to potassium chlorate, I'm going to see at 70 degrees, I can dissolve 30 grams. It reaches its saturation at 30 grams at 70 degrees. So I know that if I've put in 20 grams, I can put in 10 more because the 20 grams that I've already put in plus 10 more grams equals, oh my goodness, equals 30 grams to reach the saturation point. That's everything I have for you today. So get out there and keep practicing with those solubility curves. Have a really great day. Talk to you later. Bye-bye.